A plane is flying directly away from a bicyclist at 850 miles per hour at an altitude of 8 miles. So here's a plane. This is the speed of the plane, and this is how far it is from the ground. What is the rate of change of the distance between the plane and the bicyclist at the moment when the distance is 17 miles? So the situation is this. Say this point is a point where we have the bicyclist. So I draw a person here. So assume that this is the bicyclist. And then we have the plane. Suppose the plane is here. So this is a plane flying away from that person. And then this wind fly into this direction. So now we know that the first thing we know that the speed of this plane is 850 miles per hour. So let's say we put an axis there. So here's the axis, the ground here. The distance from the plane to the ground is 8. So this length is 8. Let's say the distance from here to here is x. So x is here. So when the plane is flying far away, then this one will increasing. And we know that the speed is derivative of this position function, right? So this one dx over dt will be 850. That's what they give us. Speed of the plane, and this is positive in this case. That's why I don't need this absolute value. It goes in this direction. So the distance from this person and this person, let me connect them to this one. I call it z. And they ask us what is the rate of change of the distance between the plane and the bicyclist at the moment when the distance is 17 miles. So let's say we have it here and the distance is z. Now at some moment the distance between this person and this plane is 17. Then we need to compute the rate of change of the distance between the plane and the person at this moment. So at the moment where when z is 17, we want to compute dz over dt, z equal to 17. So we set up the relation. So here we have a relation using this right triangle. This angle is pi over 2. So look at this right triangle. You have the Pythagorean theorems. Relation z squared equal to x squared plus 8 squared. So all we need to do is doing the derivative both sides of this equation. So z and x depends on t, right? They are function in t. Time change, this change x, distance x here, xt change, zt change. So remember, we need to use a chain rule there. So I do d over dt, z squared left hand side, d over dt, x squared plus 8 squared. So I have 2z times dz over dt equal to 2x times d over dt, dx over dt plus 0. So I can remove that 2z dz over dt, x dx over dt Now we look at the term when z equal to 17. So this term we know 17. We know dx over dt, this is 850. So at this time we can compute the values of x because of this relation. We know that x and z are related by this one. So when z is 17 square, x square plus 8 square, so x equal to square root 17 square minus 8 square. So this is square root 225, which is 15. X equal to 15. So we know this one 15. We know this one. Dx over dt is 850. So now we can get dz over dt. So plug in all the data we have. 17 times dz over dt equal to 15 times dx over dt is 850. And with that we get dz over dt. 15 times 850 over 17. So this one equal to 750 mile per hour. This is the final answer.